Great to be here at Y Data. Thanks for inviting me. Don't mess up with my slides, please. Okay, so my name is Roy. I lead the Data Guild at Waze. I'm going to explain today what does it mean to build and manage a data guild, and how do we do data at Waze. And so I assume that most of the people in this room have used Waze, know Waze in some form or another. We always joke that in Israel, Waze has 120% penetration rate, right? You have on several cars. So I'm going to speak about how do we look at data, what is our data stack at Waze, and why was it built this way, in a sense, to serve our users, our product, which is ever growing and changing, and the various pillars of data product that we have at Waze. If I'm going to try and hold this like an open discussion, if you have questions, feel free to raise your hand, and I'll do my best to answer it. Here's my contact details. If you want to, I know those are exciting. Don't worry about it. If anything that I say here sounds interesting to you, feel free to connect with me on LinkedIn, email me, shoot me a question. I'm always happy to be part of the increasingly growing data science community at Israel. Click. So I'm going to talk a lot about the data stack and the technological stack that we have at Waze. In a nutshell, we have decided at the Data Guild to do from AI to BI all the way on top of one platform, on top of Google Cloud. And I'm going to explain why we're doing this on a single cloud platform, but that's more on, that's coming up next. Let's click. Now, since I know you, it's pretty late at night now, and you all have a few beers, let's talk about something very light, the ETA Prediction Algorithm at Waze. So you drive with Waze, you choose a destination, suppose you drive from Tel Aviv to Haifa, and we need to predict how much time would it take you to move from Tel Aviv to Haifa right now. How do you think that algorithm works? And let's assume that you haven't drank beers on the way. How do you think that works? Come on, I know you did a few exercises like this at Y Data. So you have historic data, right? So you have historic data of the different segments and roads. So is it purely historic data?
Real-time traffic.
So you need to somehow combine between what is going on right now and what is historic data. Now, how would you define historic data?
You are only doing the real time.
What?
Currently, if I'm asking you, you are doing the real time.
Okay, so let's understand that for a second. Now, you're traveling, you ask Waze to route you from Tel Aviv to Haifa, and suppose that trip is around, let's say, 60, 70 kilometers, approximately, and we need to somehow combine what we know right now and what we know from the past. Why do I need to know things from the past? Because the segments that you will reach in 30 minutes from now, maybe the information that I have right now, what goes on there, is not really interesting, right?
You are doing combination?
We are doing combination. In Israel, everybody is doing combinations, right? You know this. Okay, so we are combining, in a sense, we are combining historic data and real-time data. And the real question is, how do you find the formula? What is historic data? Should you rely for the data that for segments that you're going to reach in 30 minutes just on similar past Mondays, similar how many in the past? Should you account for the fact that today is Hanukkah evening? Should you account for the fact that hundreds and thousands of people are heading to the Yandex offices for Tech Talk? How do you account for all of this information? Essentially what you're seeing here is a very narrow simplification of that question. How do you combine historic data with real-time data for that prediction of how much time would it take you to get from Tel Aviv to Haifa? Sounds simple, right? Click. Of course you can ask.
Are you looking also historic data about the user-specific driving?
Okay. On top of that, for some users who grant their consent and they want to and want that the experience will be more personalized, if, for example, you are driving extra carefully, then we are able to provide you with an estimation which is relevant specifically for you. So two people, assuming both of them apply to the personalized ETA prediction, they would get different routines, different predictions. Okay, but yeah, good question. So there is that layer. And of course, ongoingly, once you are on the road, we need to update you all the time with what goes on. So it's not only about the prediction, but also alerting you about changes of what goes on, and if there is an unexpected roadblock and so on, we need to update you and also manage your expectations accordingly. Click. You already clicked. You predicted my intuition. That's wonderful. Okay, I told you this is an autonomous slideshow. So, to be honest, I have a confession to make. I'm an economist. Yes, I did my PhD in econometrics. Some of my best friends are economists as well. And some people say that once you hold the hammer, everything looks like a nail. To be frank, I also observe the domain of transportation as a marketplace. I'm not the first person who did that. 60 years ago, a Nobel laureate named William Vickrey, maybe you've heard of him, spoke about the marketplace for transportation. Why am I telling you this, and how does that relate to Waze? You'll find out in about 3 minutes or after this slide. How can you observe, how can you look at the world of transportation as a marketplace? So, crash course in microeconomics. In economics, we look at everything in terms of supply and demand. Great. How do we look at supply in the domain of transportation? Take the the x-axis, that's the quantity. The y-axis, that's the price. Okay, it doesn't say that, but trust me, that's what it's capturing here. So the x-axis, that's the quantity. The y-axis, that's the price that, for consuming that quantity, that's the price that people pay. Now, the red line characterizes the supply for transportation. What does it mean, the supply for transportation? That's the physics of the road. So, how can I explain the physics of the road? So let's start from the red line. In the beginning, when you don't have a lot of people on the road and people join, then it's a free flow speed, right? It's a 90 kilometers speed limit. Everybody can go on 90. Let's say that they really go just on 90. They go on 90 kilometers per hour. And then when people start joining, and maybe it's 6 a.m. and 7 a.m. and 7:30 a.m., enough people are joining the specific road, maybe Ayalon Sasson, and then traffic starting to pile up. And traffic piles up very quickly. And this is what you see on the supply. You see that that's the price that is increasing. That's the price that everyone pays. What is the trouble? Now, microeconomics 2. What is the price that everyone pays? Time. Okay. What is the problem in public goods?
Nobody cares.
Nobody cares. What does it mean? What does it mean nobody cares? Now I'm going to say this like an economics professor. You do not internalize the price that you are invoking on everyone else. Essentially, I don't care. I'm putting myself on the road. Everyone behind me, I really don't care that they're stuck in traffic. So people do not internalize the marginal cost that they are putting on everyone who stands behind them on traffic. You see that marginal cost, that MC? That's the marginal cost for every additional person who is joining the traffic and stands in line, looking left to the right, standing in the same car. Everybody is alone on that car. So that's supply. Waze so far is pretty good in understanding the physics of the road in real time, combining historic time and real-time data and the information that we get from community that makes our map and information fresher. Now, so that's supply. What is demand then? Yes? What comes on the demand? Okay, so let's explain what is the demand. Okay, why is the demand with a negative slope here? Essentially, the demand is, I hope that I got your question right. What does the demand capture? The demand captures the relationship between my preferences and the time. You will tell me now it takes you an hour and a half to get to Yandex to give a lecture, I might say, you know what, Costa is very nice, but in the second candle of Hanukkah, I'm not really sure that I'm going to take that trip. If it takes, but I did take that trip eventually, so I really like Costa. If you would tell me it's 3 hours, I might say, no, I'm not going to take this trip. Maybe we will do it on Zoom. Maybe I'm not going to do it on this Monday. So that's essentially your preferences. That's what the demand captures. If you will tell me it takes you on Ayalon to travel from Rishon to Tel Aviv an hour and a half every day in the morning, you might stay at home, work from home, quit your job, look for somewhere near, might carpool, God forbid, might take a public transportation. But essentially, that characterizes the green line, shows the negative relationship between price and the affinity of people to take the road at a specific point in time. Yes, I see a follow-up question coming up. Excellent. Is like I planted him to give me the follow-up question. Fantastic. Thank you, person I've never met before. Okay, how do you change the supply, the demand? So there are several ways in which you can affect the demand. For example, congestion pricing, an idea invoked by William Vickrey 50 years ago, essentially says, okay, how can we get people to internalize the prices that they are placing on everyone else? You can ask them to pay money if they want to enter Ayalon, Sasson at congestion time. So that's the red line. What other alternatives? We can shift the curve downwards if every person doesn't take their own car, but sometimes, maybe a day or twice a week, carpool with everyone, then suddenly every car is worth not 1.1 passengers as we have here in Israel, maybe it will be 1.4, and then suddenly it shifts. Now here's a very cool thing. If you have people who are commuting to the same destination from the same origin, and it's relatively frictionless to coordinate between you two, sometimes the elasticity becomes even higher. So people are more willing to, yeah, maybe I'll exit my home 10 minutes later, but it means that I don't need to take up my car, I don't need parking, and so on. So there are lots of ways to look at the demand, but think about it just to summarize. Demand is understanding people's preferences, and supply is understanding the physics of the road. So far, so good? Great. Now you might say, yeah, but your Waze, you have more than 150 million users. You have big data. Why do you need to put all of those charts? Just look at a machine learning model, look at correlations and so on. Good, I'm happy that you asked that person that I've never seen in my life. Click, please. Even when you have real-time data, even if you have big data, this is what you see. You see equilibrium. If I tell you this is the supply and this is the demand, maybe it's the other way around, that's up to, what I said was correct, up to multiplying by -1. So that's the dots that you see. You only see equilibria. That's the dots when supply meets demand. If you look just on where supply meets demand, what will you see? There's no relationship between people's affinity to drive and when they take their car versus what the physics of the road. So yeah, it looks tough even when you have big data. Now you might say, yeah, but you're like an economist, you came from academia, why are you showing us these graphs? What does that have to do with anything that has to do with our real lives? So click, please. Okay, so there is a rule called the fundamental law of traffic congestion. And the fundamental law of traffic congestion says essentially that we will always stay in traffic unless something fundamentally changes. And you can hear those people standing in traffic outside of us. What does it mean? Suppose you have a government and that government says, we're going to invest a lot in building additional infrastructure and roads, and we're going to pave highways, and going to invest billions and billions and billions. So this is a data set from the US that shows, do you know what is the relationship between the amount investment in infrastructure and roads in the US and the amount of traffic congestion? What is the correlation? 0. Do you know why it is 0? Not because of the previous graph that I showed you. What happens if I will pave a new freeway under your house? Will you take Will you take the bus? No, I can drive alone with my podcast. I can hear the Yandex video of Roy talking about traffic congestion and carpool at the comfort of my own car. Okay, so that's exactly the problem. Understanding that there are market dynamics, and whenever you have a product, whenever you have an environment, an economic environment that people react to it, means that even when you have big data, you still don't really understand the dynamics. Click. Okay. This usual picture is mostly being presented when data scientists are talking about data science. So usually when you build a data org who has a lot of data and potentially machine learning and so on, your data scientists will want to say, yeah, we're building the Terminator, we're using AI, we're doing very cool stuff. The point that I'm going to try to make is the data scientists should not be thinking about themselves like this, but rather like, click, this. The role of data science, and you will see this as the profession grows and as it integrates with analytics and data engineering and various infrastructure that I'm going to talk about today. The role of data scientists, even those who are building machine learning affecting production systems, is to build your org's Wikipedia. Why Wikipedia? Why do you think I'm talking about Wikipedia and not about the Terminator? Why Wikipedia? What's so cool about Wikipedia? Knowledge accumulation, standing on the shoulder of giants, building gradually what your org understands about the users, the market, the dynamics, and so on. So the roles of a data org and a data guild is essentially to get from AI all the way to BI, both the end users to be smarter based on the cool machine learning projects that we put in production at the hand of the user, but also informing the user as they navigate with Waze to understand what is up on the road ahead of them. Maybe build products that inform them, hey, you can carpool and reduce traffic, and maybe you can save time if you will go on the HOV lane. You can do all sorts of things by analyzing users' behavior and then integrating this as part of your yearly planning and understanding which metrics you should be looking at, which metrics should you choose in order to measure user engagement. So all of these things, I like to look at them as the role of the data guide is to accumulate knowledge. Click. By the way, knowledge accumulations mean that in the beginning, maybe go backwards, sorry about that. Knowledge accumulation means that in the beginning, you might be not that smart. So maybe you remember, those of you who are as old as I am, when Wikipedia was in the beginning, the concept of building an online encyclopedia that is built on a community of people who are contributing and auditing each other was something that was unheard of. Remember, we had every person in Israel, at least, when they reached their bat mitzvah or bar mitzvah, they got like a big Hebrew encyclopedia. It filled up an entire shelf. Maybe you remember also there was an episode in Friends where Joey did not have enough money to buy the entire encyclopedia, so he bought only one chapter of it. But essentially, you had like a lot of smart people sitting once every couple of years and updating everything. But today, it seems very obvious to all of us that encyclopedia and when you want to ask something and verify something, you will go to Wikipedia. You will not go to the Encyclopedia Ivrit, because Wikipedia is much more accessible, up to date, and they have the peer-to-peer auditing system, and that's critical. So that's how an org, a data org, should be behaving as we built it at Waze. You have data scientists, you have product analysts, you have engineers, you have PMs. A lot of information is flowing all the time. And Waze, in fact, is around 4 different product pillars. Everybody knows us just as the navigation app, but Waze also have a data sharing program with municipalities. And we have the ads business, and we have carpool, and we have the experience that you have when you're planning a drive, and you have the experience when you're navigating. All of those things account for different behaviors. Now let's click. Okay, so essentially, I gave a very long introduction of why you should know economics. We gave introduction to microeconomics 1, introduction to microeconomics 2, a little bit about Wikipedia. And now essentially, what is knowledge at a company? At every company, look at pretty much any company that did an IPO in the past couple of years, they have some form of flywheel. What is my company's flywheel and how do we grow? Understanding, look at Uber, look at Lemonade, look at any company that did any IPO in a form, you need to have some belief and some worldview in terms of how do we grow. And the idea of product development in many cases is about adding additional flywheels that tap into the existing flywheel. So here is just a very simplified example at Waze. So in Waze you have driving and reporting. Why do you tap into Waze? Why do you use Waze? Because it has real-time data. It has, everybody is using Waze, right? So everybody is on the road. The data that we have is more accurate. The more accurate the data, the more people will join. The more people will join, the more accurate the data would be, right? So that's data network effect. Essentially, every person who joins also reports sometimes, so that makes the data even more valuable. Now, what you see on top is a result, is another flywheel, which comes as a result of a product analytical insight. A few years ago, we used to see that around half of the people who use Waze, no, not one, about a third of the people who use Waze use us like this. You open Waze, suppose in 30 minutes this will all be over, we'll have a couple of more drinks and we'll go, no drinks, yeah, it's driving. And we'll need to go, so I will open Waze, check how long it takes me to arrive at home, and I'm going to close Waze. And then later I'm going to drive. So this behavior can be interpreted by two different product analysts with a completely opposite direction for product development. One product analyst might say, hey, those people who are just using us to check ETA, right? It costs us a lot of money to calculate the route for them, and then they don't drive with us, they don't see commercials, they don't even give data away, right? You're not using the turn-by-turn navigation, so you're not even giving data for helping other people to make their predictions more accurate. That's not a good thing. We should make sure that these people don't have access to the app. Just kidding. No, we don't do that. Another product analyst might say, okay, I have another theory. What is that theory? I'm planning, I'm preparing to my trip. I don't know when I should be leaving. And then when I go already to the car, then I say, okay, well, I don't really need to use Waze because I know the road there. So I'm just using you in order to tell me how long would it take me, and I'm essentially preparing for the trip. That kind of introspection can only come from people who understand those graphs that I showed you. Because the data itself can tell you one thing and the opposite about user behavior. And that's a critical point. Because you can build entirely different flywheels to your company based on the same observation. And it doesn't matter how much machine learning you've done and how much Java and Python you know how to deploy into production. You can take the same data and interpret it in two opposite directions. Click, please. Someone's raising a hand. Okay, so how do you build a data guild stack on the professional level that makes sure that people integrate their insights like this and accumulate the knowledge and understand, okay, those people who check their ETA, they're actually trying to tell us something that the service is not doing. So this is what we've built at Waze. We have mainly four different data professions at the Data Guild, whose single role is essentially to build the Waze Wikipedia and accumulate the knowledge. Click, please. So those are the data engineers, our friends, the data engineers. These are the people who account for the infrastructure from AI to BI. So all of the stack that I'm talking about today, by the way, I'm a big Lego fan, so you'll see this motif returning quite a lot, so expect that. So what do data engineers do? Data engineers essentially build the infrastructure that heavy lifts the services the data scientists and product analysts and business analysts are relying on. And the idea is this. If a data scientist is building a model that predicts the ETA and measures how good of experience did we give you in the accuracy, you want to make sure that later the product analyst who is relying on the results of the ETA that we gave and the experience that users have speak in the same language in terms of metrics. So it's okay that the data scientist will build a neural network and will estimate his results based on accuracy or MSC or whatever metric we choose. But eventually the product analyst need to determine, was this a good experience or a bad experience? If the product analyst does not speak in the same language as the data scientist in terms of metrics, in terms of even characterizing what is a trip, what is a drive, what is a user, then the results and the insights that the product analyst will bring is in most cases pretty much nonsense or non-actionable, even if they did a great job, because the data scientist cannot apply any changes in the experience based on insights from the product analyst. So data engineers supply the infrastructure for data scientists and product analysts and later and later also management to speak in the same language, in the same metrics, and also to have the same data stack so that the data warehouse or the data lakes is very close to production systems. So the accuracy and the result of the trip that the user has gone is very fresh on the data warehouse and speaks in the same metrics and the same features. So data engineers are essentially the Hulk who is holding the infrastructure. They're doing a lot. You can see this mapped in terms of red and green, but you get the idea. They optimize the system. They optimize the culture. Now, in many cases, they hang around like the Hulk, pretty upset and mad, or why did you do this, and why did you build something that cost so much TI, and so on. But don't forget something important. Click. If you're an Avengers, if you're a Hulk enthusiast like me, you remember that the Hulk is also a scientist. So the Hulk knows how to build stuff properly. He's a scientist and he knows how to speak to scientists. Okay, so it's not only it's also someone who's very smart and essentially makes everyone smarter around him. Click. What is a full cycle data scientist? Click. Click. Okay, this is your full stack data scientist, right? Why did I choose Iron Man? They full stack data scientists. They really love themselves. They enjoy their work. They have lasers. They do cool things, right? They do awesome things, right? They do machine learning and so on. People sometimes forget that a lot of their work is also, cleaning up the data and preparing it and so on. But I think the thing that resembles the most data scientists is Iron Man. Now, what do full stack data scientists do? The idea of how we adopted full stack data science profession at Waze is the data scientists do everything end to end. So for example, let's take that data scientist who built that new ETA prediction algorithm. That data scientist will also speak with the product manager in the sense of characterizing what is a good metric to measure his new algorithm on. So it's fine that the data scientist measures his algorithm based on MSC, but the target that the product manager should be placing is something that actually talks about a good session. Now, what is a good session? How would you characterize a good session? Don't answer it. If you answer it, email me later. Maybe we'll set up an interview. Anyhow, so it's hard to characterize a good session from a user's perspective. What is a relevant ad? What is a good time-saving experience in terms of me identifying your routines and sending you a push notification 20 minutes before you hit the road to tell you, hey, There's a lot of traffic from Yandex to your home. Maybe you have a couple of more beers, not beers, Diet Cokes. So how do you characterize that? If the data scientist is not full stack in the sense that the data scientist is only focusing on the model, then the insights of the user experience will not reach well the end users. That's the idea of a full stack data scientist. Behind it, you will see a lot of green. Click. So, what is a product analyst? Product analyst, okay, this is more challenging. The people who are laughing now, these are really Avengers enthusiasts. So that's Captain Marvel. Essentially, what is Captain Marvel all about? She brings insights from all over the universe, not only from what the users are experiencing, but also from external to the company, what goes on in the business, how do other companies measure themselves in terms of good experience, in terms of routing, and so on. So product analysts essentially are analyzing user behavior, analyzing the marketplace, and the role is to separate between causality and correlation. The data scientist looks at correlations. They only look at the dynamics of what goes on with the ETA or with the prediction of the specific model that they're doing. They're not modeling the long-term dynamics of what goes on. So think, for example, about the marketplace for transportation. A data scientist using the toolkits that data scientists have will not be able to predict or give even some indication of, hey, suppose there would be a new HOV lane introduced from Netanya to Tel Aviv, what would that do to the dynamics of how much people tend to carpool? What do we expect people to do in terms of how they commute? Not only about carpool. For example, we would expect that, and you see this by the way, you see that after the introduction of HOVs and essentially people chose to carpool quite substantially more, but many people, because in some of the roads they just took one of the segments and so it took you longer to get to Tel Aviv if you didn't carpool or take the bus. Then some people just said, no, I'm not carpooling or taking the bus, no way whatsoever. I'm just going to go to work 2 hours later. And you see this, by the way, also in terms of understanding the dynamics of traffic here in Israel. So you see what happened in COVID. You might say, hey, everybody is talking all the time about the fact that if we can just take 10, 15% of the cars off the road, then our traffic problems will be solved, right? Well, maybe you haven't heard of it. I know that. That's my word. But about 15% of the cars off the road can resolve a lot of our pkakim, our congestion here in Israel. But you don't see that, right? What are we doing now in COVID? About a significant proportion of people are working from home. Many people are not commuting to work anyhow, but do you sense that there is less traffic? No. Why is that? The fundamental law of traffic congestion. You saw that, right? Which is, I think, what you were trying. But? If what? During the lockdown, yeah. If nobody travels, then it's okay to travel. That we also know that for sure. That's also something. I don't recommend this, but yeah, when nobody travels, we see that. It takes a very short time to get from Tel Aviv to Haifa. But in the middle, in everything in the middle, we are kind of in a problem. And understanding that dynamics is something that only a product analyst can do. The data will not tell you that as is. And in fact, what we see now in the data for Israel, let me take a sip for my Diet Coke. And what we see actually is that traffic is getting worse. You all feel this. And not only that, it's an underestimation of how much worse it is. Do you know why? Two things. First, people are working from home. So you see that it takes you longer versus in the past, versus 2 years ago, to commute in the most common routes. So that's one thing. And you see another thing. You see that people start stretching the time that they leave home. So for example, how are we doing in terms of time? How are we doing in terms of time? Okay, I'll just keep blabbing, no problem. I'm guessing that Costa is having fun, so he doesn't want me to end. How are we doing in terms of time? 15 minutes? No, we need more. No, I'm kidding. We'll manage. So what you see is that during the morning commute, traffic is pretty much the same if you will go on the rush hour in the morning, but it just stretches across more time. So from 6:30 a.m. on the most common routes, from 6:30 a.m. if we used to have like this peak in terms of time, now the peak is just like a big mountain. So from 6:30 all the way to 11, it takes the same time as in the past. Where do we see a larger peak? In the evening. In the evening, you have a hard stop, right? What is that hard stop? You need to pick up the kids. You need to do, you get fed up of your boss. You have to leave. Many things, but essentially you have a hard stop. You have a hard stop and you need to leave. And there you see the peak. Now, a data scientist is not equipped with the tools of understanding and analyzing that in a sense we have here an underestimation of what happened to the traffic congestion. And this is just one example. So that's the product analyst role. The business analyst is very similar, but they're not looking internally into the tools that we provide for all of the stakeholders that we have in the org in order to understand the dynamics based on user behavior. They bring data from outside. What do other services do? What do other services see? Which data can we bring from outside that can actually enhance our capability to understand what goes on in the market? Click. The role of the data guild is to do this, to take all of those very smart people that have a lot of interacting superpowers and to supply them with the infrastructure and the culture of becoming the Avengers. That's the idea that I chose to present here. What? Who's Thor? It's a data engineer gone data science, then he came back, yeah. He has a hammer, yes. Click. Okay, so just a few takeaways. But again, the idea is that everyone does everything. If I need to summarize the table that I showed you, everyone does a different mix of everything. Nobody just does, I'm a thinker, I'm building deep learning models and then passing it to a machine learning operations engineer that would put this in production, and later it will pass to a product analyst who will interpret the results and will tell us what do our users feel and experience based on the new algorithm. It doesn't work like this. We have a mixture of all the different skill sets and the roles in each one of the Avengers. So just a few key takeaways of what I've seen and how we've built the data guild at Waze. First, roles are interconnected. The data scientists need to be able to speak with the business analyst in the same taxonomy. Taxonomy is a word that I speak a lot of, but that's essentially, if you think about the knowledge graph of Wikipedia and what they maintain, those hyperlinks, that's the most important secret component of creating the culture. You can hold it in a spreadsheet and you can do like a fancy G3 docs or all sorts of infrastructure using data catalog to do automatic annotations of understanding the different metrics and so on. But essentially, when the business analyst and the data scientists are talking about a user, they're talking about the same thing. When they're talking about a trip, they're talking about the same thing. When they're talking about a bad experience, they're talking about the same thing. When they're talking about a congestion, they're talking about the same thing. So that's roles are interconnected. And there's no separation between builders and thinkers. Nobody would deploy the machine learning model the fancy machine learning model that you build into production. You need to build it yourself, and you need to deploy it yourself, and you need to wake up in the middle of the night if it crashes. Yes, that was a crash. So that's the idea of a full cycle data scientist. So don't separate between those two, because then the ability, by the way, the data scientist should want this as well, because otherwise, if you see many large organizations, well, they have like a moving line, an assembly line. You have the data scientist building a model, then a data engineer putting it into production, then a product analyst shipping it and understanding what went on there. Then the connection and the knowledge accumulation, the loop there is much, much slower. Click. No click. No, please don't click. Garbage in, garbage out. The idea of monitoring the data and making sure that it is clear in the taxonomy, and that a product analyst can code review a data scientist and a data engineer can code review a business analyst, that is critical for making sure that knowledge and metrics pass and the understanding of the product passes from different parts of the org to another. So someone told me this once about 8 years ago, and I take this very seriously, even when I manage data scientists or product analysts and so on. Remember that Iron Man, everybody likes the lasers and so on, but our ability as data scientists to implement and change the world and make like big things using fancy machine learning, they can affect the flywheel of your product maybe by tens, hundreds of percentages. If you're like a super duper data scientist, you built a new model that makes super duper accurate ETA predictions. But as a product analyst, the ability to bring a key insight, for example, like the one that I gave you, simple one that just shows, hey, those people who are checking their ETA, they're trying to tell us something. That can impact your product by hundreds of percentages, because you understand the dynamics. And what the data science shows you in the modeling, remember, it's always about correlations, even the fancy machine learning model. So we have to make sure that the insights from both parts are all shared. We have at Waze a shared infra all the way from AI to BI. AI to BI, A to B, you see the things in Waze. You didn't like that joke? Fine. But it's a shared infrastructure. It's a shared infrastructure in the sense that the same dashboard that the modeler who does the ETA will build will be in the same data studio that later a product analyst will use in order to interpret how did we do last year and what should we build. So, and we still allow for some latitude and flexibility so that not everything has to go through a lot of reviews by separating between lab and production. If you want to do something which is quick and dirty, you want to play a little bit with exploratory data analysis, it's fine, you can do this, and you don't need to go under code reviews, you don't need to have unit tests and so on, but you need to make sure that your communication is limited. So you cannot communicate your insights outside of a very narrow squad or a circle of peers. You cannot send this to the entire org. That's like for all of engineering. So that's like the sort of a whip of whether you should be productionizing or doing lab. Your knowledge and the insights would reach a narrower audience. We also try to arm our ambassadors in the sense that we give people access to data, but it has to be confined with a clear taxonomy. And again, everyone should be able to query the data and have a look at it. But if you want to communicate, and remember, one of the troubles when you have data which is very accessible, and it's very easy to see this, by the way, today, right, in COVID. You have lots of data which is accessible to everyone, lots of research that everybody's talking about, and still we cannot agree on what is the right treatment for COVID. Don't forget that even in the beginning of COVID, many people were not convinced that masks are critical for not infecting. By the way, a lot of people here are not wearing masks, and this is recorded, but just saying. Anyhow, you got the idea. More data does not indicate more knowledge. The role of a data guild is to accumulate knowledge. Click. How are we doing with time, Costa? 5 more minutes. Okay, so we leave time for questions. This is like a general framework of all the tools and the ecosystem, the learning ecosystem that we have at Waze. So you have the visualization tool, you have to have knowledge accumulation, everything goes to a unified taxonomy. You have a data store, you have a KPI store, you have a feature store. All of these things are essentially making sure, and you can do fancy stuff like on top of GCP, or you can just use a spreadsheet to map in if you're a startup. Make sure that you understand what does the user definition means. What does it mean that certain behaviors mean? And those are incorporated in the pipelines that analysts are creating. It should be linked to the experimentation framework because you want that the experimentation framework will automatically monitor the specific metrics for the specific slices that your org has decided which are insightful and meaningful. Click. That's our infrastructure stack that serves the full cycle data scientists and the product analysts and so on. Everyone is on top of GCP. That's it. No hybrid clouds. Even in some cases, even if there is a specific feature that one data engineer really likes, we will really refrain from adopting another completely stack unless it is something which is quite critical, because the unification of processes is critical, especially when you have, like in most of the cloud platforms, not going to sell you GCP, but in most of them, but you should, no, I'm kidding. But most of the cloud platforms have like end-to-end solution to pretty much anything. So be wary in terms of adopting another tech stack that have like this cool feature or just convenient to this data scientist or that product analyst, because it comes with a major cost. Click. One last thing, because I had this slide. Very good friends of the Data Guild, which are not part of the Data Guild, are our friends who do small data. Who are those people who do small data analysis? No, the users have like micro data, but still, they work at Waze. Who is working at Waze, does small data analysis? UX research. Never underestimate the power of a good UX research analysis based on 10 users. Product analysts have to work very closely with UX researchers in order to understand from the past behaviors, identifying, remember that example, why is that user checking the ETA? The why can only come, well, it can come also from why data, but the why can only come from actually asking the users. So the value of incorporating product analytical process with UXR is critical. Why am I showing this with Lego? So there is a very nice, probably a tale, but whatever. I'm going to tell this. Nobody fact-checked these things. That Lego, about 15 years ago, was about to go bankrupt. And why did they go bankrupt? Because they adopted the wrong strategy of how to change their product. They said, we need to do more movies and video games and bigger blocks because kids don't really have the attention span to build those tiny things. So we need to do things for kids who are impatient. And then they took a UX researcher, a very famous one, who has like a very weird habit of methodology of sleeping at the houses of the people that he researched on. Don't ask me, I don't think that this would be legal today, but anyhow. So he visited a few families, and he visited a family of a small kid. Yes. And part of his research and so on, he used to live for a few days with the people that he researched to learn about their habits, to understand those people. And he walked into the room of that small kid and essentially asked him, what is the item that you have that you're most proud of? And the kid showed him his sneakers, and he asked him, why do you like your sneakers that much? He thought he would tell him like a PlayStation or something like that. And the kid told him, because you see that scratch that I have here, this proves that I'm the best skateboarder that we have in my block. And based on that insight, he understood that kids have something else that they're seeking from their toys, from the habits, and so on. So making larger Lego blocks, making it just easier on them, That's actually the opposite of what they should be doing. And based on that, that's what the story says. Lego adopted a completely different strategy of Ninjago and all of the cool things that you see now on Lego, where the building blocks are much smaller and the mastery part is actually much more enhanced in the experience. Now, you can believe me or not, it's not my story, it's the Lego story, just indicating what you can get from UX research and from very deep analysis of specific users. But again, the most important aspect I want you to take from this slide is that Lego did a lot of evolutions, and second, that integrating big data and small data is quite critical to understanding the why of the users. Click. So, you know that, right? But I hope that you took from my conversation, click, that you have to have an opinion. Okay, everyone has data. And it's not really a trick to manipulate and to aggregate data and to build dashboards. The idea is, what can we identify, what does the data tell us, which is sometimes the opposite of the correlation. Click. Because otherwise you're just seeing noise even when you have big data. Thank you.